Okay, how are we gonna do this problem here?
Don't you bring down the 5 and x when it equals x times 2 with the parentheses over here?
Well, say that again. Say that one more time.
You turn the 5 into x.
Yes, you do. Okay. So we can condense this left-hand side, right? We can condense that since they're being put together attached by a plus. We can actually write that as log base 2 of 5x, right?
Right.
Equals log base 2 of x plus 20. Now, when you have the same base, which we do in this case, we can now drop the logs and say 5x is equal to x plus 20.
And then do you subtract the 5x from the distribute?
Subtract the 5x.
So it's negative 5x times x plus 20?
Negative 5x times x plus 20?
Oh, no.
Did you write this part?
I didn't drop the parentheses.
Okay, well, the only reason I have the parentheses is just to show it's log base 2 of both those. Like in the calculator, you put in parentheses. Yeah, but right here, you don't have to keep them at this point. Now you'd want to subtract x. You end up with 4x is equal to 20. Divide by 4, and you get x is equal to 5. All right. Sequoia said it checked out. It's a very easy check. You can just plug 5 in right here and right here. One thing you want to check out, does it make any of our logs negative? Or are we going to be logging a negative number? No, it's not going to make anything negative. That's going to be 25. We already had log base 2 of 5, log base 2 of 5. A quick check, remember when this is separated by addition, you could rewrite this as log base 2 of 5 times 5. So you'd have log base 2 of 25 equals log base 2 of 25. So that's a quick check for that. All right, do you guys both have calculators? You're going to need calculators for this. Not for this next problem, but what's your question?
One of the problems on homework,
Uh-huh.
the question was log base for, like I got the answer.
Okay, this is an exponential equation. The reason why this is an exponential equation is because there's a variable in the exponent.
Isn't that just 5?
It is just 5. You're right. Just to be clear, x squared equals 25 is not an exponential equation because there is no variable in the exponent. This constitutes an exponential equation because there's a variable in the exponent. All right, so in this case, we know that this is just 5. X equals 5, right? We could rewrite that as log base 2 of 32 is equal to x. So 2 to the what gives me 32? 5. So this is obviously x equals 5. But what about this one? Have to be a decimal. This is similar to something I gave on the test when I said between what two integers is x. Could we figure out between what two integers x is? Where is it? What two integers is x between?
What do you mean?
Well, I don't know what x is. There's no way off the top of your head you're going to be able to figure out exactly what x is. But you can be approximate. If I asked you between what two integers,
Probably 4 and 5.
why do you say 4 and 5?
Because 2 to the 5th power equals 32. So
Right. 2 to the 4th gives me what?
16.
16. So to get 30, you obviously should be in between 4 and 5.
Right.
But we don't know exactly what it is. You could do guessing and checking on the calculator, but we want a different way. And we have a different way we can do it now. So what you can do, when you have equations, you can multiply both sides by something, you can divide both sides, you can add something to both sides, subtract. Another thing you can do is take the log of any base of both sides, as long as you take the same base on both sides. So we'll do log base 10 since we have that in the calculator, nice and easy. All right, so we can do log base 10 of 2 to the x equals log base 10 of 30. All right, now, next thing we can do we can take this x, move it down here. Now we have x times the log base 10 of 2 equals log base 10 of 30. Anybody know what we would do next? Well, we have x times this. We're looking for x. We can just divide by log base 10 of 2, log base 10 of 2, like that. This just cancels out to 1. Anything divided by itself to 1? No, no, be careful, be careful, be careful. Log base 10 of 30 divided by log base 10 of 2 is not equal to log base 10 of 15. And we can even check that in the calculator. Look in the calculator. If I go and I do, so if I do log base 10 of 30 divided by log base 10 of 2, this is what we get right there, right? And that looks like what we should have for our answer, between 4 and 5. Now, if you just do log base 10 of 15, look what you get. It's not the same value. So don't make that mistake.
I had got 4.91.
When you did log base 10 of 15,
No, when I had got
when
Like when you just try to do it.
when you just put in your head,
yeah,
and what did you get?
4.91.
That's where I got.
Okay, now if I asked you to round to the nearest thousand, you could probably get kind of close, like you did. Sounds like you got pretty close. If I wanted you to round to the nearest thousandth, what would this be? 4.906 or 7?
Seven.
Oh, yes, sir.
That 8 makes that go up, so we'd have 4.907. So let's go and write that. All right, so this would be x equals. Now, this is an exact answer, and I talked to my other classes about this. This is an exact answer.
So you could leave it that way.
You could, unless they ask you to round it. And if I'm asking you to round to the nearest thousand, we want to have x. And I want to go like that because really it doesn't equal, we're approximating. And we said 4.907, is that what we said?
Yeah.
Now, look what happens. If I go back in the calculator and I do 2 to the 4.907, look what you get. Now, why do you think you don't get exactly 30? Because we were trying to find what exponent, 2 to what exponent would give me 30. If you put 4.907, why don't we get 30?
Because it's not like exactly that old.
That's right. What we estimated that. Now, how could I change that to where we would get 30?
We'll have to keep.
You put in the whole thing.
Yeah, you'd want to put in, you might actually, I don't know what would happen if you put in all those, it might work, but I'm sure it would work if you put in this right here. So I'm actually going to go down and do that. Try that. See if that works. So if you do 2 to the log of 30, log base 10 of 30, divided by the log base 10 of 2, what do you get now? You get 30 because you have an exact answer. Now, sometimes it'll be okay just to plug in all those numbers. So if I did 2 to the 4.906890596, I don't know what that, I want to check that.
What that number was just right
I don't know, I'm going to check it actually. So I'd have to remember that number. Does someone have that number in your calculator?
4
there. Yeah, I got it.
906
8.
89.
Yeah. 0, 5, 9, 6.
See, even with that, it doesn't even do it. So you got to be careful with a lot of these problems, especially when you get up to a higher level. You have to make sure and round at the end. All right, because if you rounded this problem, even when you know, I've had students tell me that their teachers told them to put in every number, and that works sometimes. In this case, you see that it would be a little bit off. So just be careful. Just be knowing that our exact answer is log base 30, I'm sorry, log base 10 of 30 divided by log base 10 of 2. Once you round it, you're, changing the value. But if you're asked to round to near 1,000, that would be correct right here. All right, now let's do the next one. What about this one? You can try that. Okay, again, what should our number be approximately? It should be between what two numbers?
Probably
3 and 4. Why between 3 and 4?
because five to the third is 125 and five to the fourth
5 to the 4th
is
is actually 625, but it's much bigger. So we know 5 to the 3rd, like you said, is 125. 5 to the 4th is bigger. So we know that our number should be in between 3 and 4. So we start off that way. I like doing that because that just helps me to know at the end, am I getting an answer that makes sense? So in this case, I'm going to use the natural log. So I'm going to take the natural log of 5 to the x, each equals the natural log of 212. You can use any log. You could do log base 5, log base 10. Natural log and log base 10 are easier because we have them on the calculator, readily available, without too much fussing. So now, what's my next step going to be? I'm going to take this x, move that down. So I'm going to have x times the natural log of 5 equals the natural log of 212. Now what would be the next step? Divide. We want to divide by this natural log of 5, divide by the natural log of 5, and we get x is equal to the natural log of 212 divided by the natural log of 5. Now we put that in the calculator. And so I have the natural log of, so natural log is this ln. That's just log base e. So the natural log of, what is it, 212?
Yeah.
So 212 divided by the natural log of, what's the other one? 5. All right, is that what you got? All right, so did you use log base 10? When you did in the calculator, did you just hit this log?
Yeah, I just did I did log 212 divided by log 5.
Yeah, so if you hit log of 212, that's really log base 10. When I use ln, that stands for log base e. E is that number 2.718, da 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 da. So you use log base 10, so you did this. Log base 10 of 212 divided by log base 10 of 5. Hit enter, you got the same answer, right? It doesn't matter what you do on both sides. You can do the natural log, you can do log base 10, you can do log base 5. That part doesn't matter. So we're going to have to the nearest 1,000. We're approximating now. 3.328 or 9? Round to the nearest thousandth. Is that going to be 3.328 or 3.329? Yeah, so we're going to have 3.328. And it makes sense because you just said that we should be in between 3 and 4, which it is. All right, what about this one? All right, so looking at this problem, what should x be approximately?
Something that we made. Wait, so is that raised, like, is the 10 raised to 2 already?
No, it's 10 raised to the 2 times x.
So whatever is 2 times x, and then it's 10 raised to
Right.
So that number would have to be smaller than 1.
Which number, the x?
Yeah,
Why?
because 10 is raised to 2, it's automatically more than 2.
That's right. So based on what you just said, we can make a guess if x was 1, then 10 to the 2 times 1 would be 10 to the second, which is 100. That's too big. If x were 0, 10 to the 2 times 0 would be 10 to the 0, which is 1. So we need a number in between 0 and 1, right? So that's a good thing to start with. So at least we know that. All right. So let's start going from there, though. We can use log base 10. Again, I don't have to write the 10. So log base 10 of 10 to the 2x equals log base 10 of 52. Remember, there's nothing written. It's a log base 10.
Then you put 2x in the front.
Then you take that 2x and we move it here. We have 2x log base 10 of 10 equals log base 10 of 52. Now, go ahead.
Do you still go now? Okay, since now we know that this got a 2 in front of x, do you still divide log 10 on both sides?
I would do that, but also you want to think about, do we know what log base 10 of 10 is? So log base 10, remember there's a 10 here, so really if you have 10, log base 10 of 10, it's saying 10 to the what gives me 10.
Right.
Yeah, anytime you have the same base as what you're logging, it's always going to be 1. So this value right here is just 1. So this entire thing is just equal to 1. So what's 2x times 1? Just 2x. So we can actually just write 2x is equal to log base 10 of 52. Now, if you did not see that, if you did not see that log base 10 is 1, you would do this. You'd have 2x times the log base 10 of 10 equals log of base 10 of 52. You could divide everything by the log base 10 of 10. So we'd have log base 10 of 10, and you'd have 2x is equal to log base 10 of 52 divided by the log base 10 of 10. Now, what's the other thing you'd have to do?
Cross multiply. Right?
What's that?
Can you cross multiply?
No.
You would have to divide that side.
Could you cross
Would you
multiply?
multiply
If you cross
two?
multiply, you'd end up with logs on both sides again. I know, and that might seem like you don't want to cross multiply. All you do is just divide by 2. So you'd have all of this divided by 2. Okay? If you did not see the fact that log base 10 of 10 was 1, if you saw it, you just end up right here. And now, what's the next step that I do here?
Divide
By 2.
to 2.
So we have x equals the log base 10 of 52 divided by 2. Right, so let's plug that in. Remember what we're looking for, a number in between 0 and 1. So we have log base 10 of 52. Close your parentheses, don't forget about that. If you don't close your parentheses, it's going to be wrong. So log base 10 of 52 divided by 2 is equal to 0.858.
I didn't get that.
No, you probably put that on. I just did the same. Because I got it, because I finished that one over here, and now I'm going to do this for check.
Did you get it? You also could have used the natural log. So if you did the natural log of 50, actually it would have changed then. Actually, you could have used natural log, but it would have changed some things. Not much, but. So what's our answer? Point
8.8.
x equals approximately 0.858. Yeah, so we're going to divide the 3. So we're going to have 2 to the x plus 4 equals 350 divided by 3. Now, if you put this in the calculator, you get a decimal. I would not do that until the very end. I would use this fraction. This is an exact value, this fraction. Once you put in the calculator and you write, I think it's like something 0.667 or whatever the case, then you're rounding. So I'd keep it as an exact fraction and not round until the end. All right, so now I'm going to use the natural log this time just to do something different. So I'm going to take the natural log of both sides. So the natural log of 2 to the x plus 4 equals the natural log of 350 divided by 3. And what can we do at that point? At this point? What have we been doing with our exponent?
Who you? I,
Jerry, what do you?
I would say you divide by the element too.
Well, not yet. Remember our last example, what did we do? This part?
Oh yeah, you did.
You know, we did this part.
You bring the exponent.
So same thing, we're gonna take this, that part,
I
right?
think you had to, I was thinking that you had to divide the element two first, so the exponent will come down.
No. When you have it, once you set it and you log it, you take the log base anything of a side, now you can legitimately move that exponent down and make it a coefficient. So we're gonna do that right here. So now we're gonna end up with x plus 4. Make sure you put parentheses because it's the x plus 4 times the natural log of 2 equals the natural log of 350 divided by 3. If you don't put parentheses, you might just think it's 4 times the natural log of 2, but it's x plus 4, the entire thing times that. All right, so now, Jerry, we can go to your step. We can divide both sides by the natural log of 2. Incidentally, if you use log base 10 on both sides, you get the same answer. So we have x plus 4 equals natural log of 350 over 3 divided by the natural log of 2. And now, is x by itself yet?
No.
What's the last thing we'd have to do? We have to subtract that 4. So I'm going to subtract 4, and what we end up with is x equals the natural log of 350 divided by 3, all over the natural log of 2, all of that minus 4. Now you can put in the calculator and round from here. Put that all in the parentheses. Yep. So we're going to have natural log of 350.
I got x equal 2.866.
All right. Let's see. I'm doing. Okay, so I'm going to do this with a fraction. So the natural log of 350 and 2, and then what do we have? And then divide by 3, divided by the natural log of 2. Okay, so divided by the natural log of 2, and then all of that minus 4, and you get, did you get that? 3.4? Let's see, let me just make sure, I'm going to put it like a fraction just to make sure I am. Okay, so on the bottom, or on the top, I need natural log of 350 divided by 3. So I have this, I'm going to do natural log, but then I'm going to have to do my fraction again. So I'm going to have 350 divided by 3. I had 2 here. I think that was my problem. I had 2 instead of 3. Green button, Y equals enter. Yours might not be updated. Natural log of 2, and then all of that minus 4, 2.866, right? So I think my issue up top was that I had a 2 instead of a 3. I think my way up here would have worked, but I put in the wrong number. So no matter what I did, that wouldn't have worked. So 2.866. So we have, what's that?
That's the final answer.
Yep, approximately 2.866. Always keep in mind what they're asking you to round to. Remember, natural log is equal to log base e. That's just shorthand. So when we have an e, it'd be good to use log your natural log. All right, so what are we going to do here? You want to divide 2 first. You want to do your deal with that 5. So subtract 5. We have 2e to the x equals 110. Now, we all know what e is. Does everyone know where that is in the calculator? Let's just go to the calculator. Where is e? Huh?
Second,
Okay, yeah. If you just want the number e, you go second division, and that gives you that 2.718. Dot 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 dot. If you want to have e with the
second,
second ln. Now, if you hit enter there, it won't show you the value of e. It'll let you do an exponent. But if you just want to see the value of e, we can look at it there. So natural log is just log base e. All right, so going back to our problem, we want to divide both sides by this 2, right? Because the e is being raised to the x power, but not the 2. So we can divide by that 2. So we're going to have e to the x equals 55. And now we want to take the natural log. You could do log base 10 on both sides, but the natural log is going to be easy, and I'll show you why. We're going to take the natural log, both sides. We're going to have now natural log of e to the x equals the natural log of 55. Now, when you have, what can I do with the exponent now?
you can break it up.
Yep, we can bring it down. So now I have x times the natural log of e equals the natural log of 55. Remember, natural log is the same as log base e. So, yeah, if I have log base e of e, anytime you have the same base as what you're logging, what's that always going to give you? Always going to give you 1. The log base 7 of 7 equals 1. Log base 5 of 5 equals 1. Log base e of e equals 1. So this part right here, just equal to 1. So what do we have on this side now? We just have x. X equals the natural log of 55. So what is the natural log of 55? Get that? 4.007. So x is approximately 4.007.